Welcome, guys.
Yes, another exciting week here.
Yeah, Extract Talks, where we meet you where you are to give you the information that you need. Theory guides, data decides. I had it in the back of my mind, theory guides, experiment decides, but because that's the original, just so you guys know that. I ripped off the original from Professor Kolthoff, who came up with the moniker theory guides, experiment decides. So this is a slight innovation on it. It's okay, theory guides, data decides. I hope that it's honoring Professor Kolthoff. Essentially the inventor of many of the techniques of analytical chemistry, very much so involved in vulcanization of rubber. He was prolific, wrote over 1,000 papers on analytical chemistry. So we're going to continue on our series on GMP fundamentals of product and process considerations. And just so that you guys know, we produce all kinds of resources.
Oh, tons of content. The podcast, product tours, mini courses, the guides, everything from extraction, distillation, terpene collection.
Yeah.
Chromatography. Yeah.
This is what we've been talking about for weeks now. People are getting bored with us now. But yeah, ICH, which is the guidance on production of APIs, of course. And there's lots of different Qs here. We got Q1 all the way through Q14. We've been talking about Q7, chapter 19 specifically. We've talked quite a bit about quality risk management, interweaving it through all of our discussions. Right? Yeah. We had focused just recently on this Q9 and the Q7, which is really talking about good manufacturing practice. Specifications are important. Why are they important? You have to create specifications for your APIs, all your starting materials, all your excipients, all that stuff. Specifications are what you measure against. If you don't have a good specification, you won't have any way to reject the API.
Okay.
My API is supposed to be 99.9% pure, and the other 0.1% is this other stuff that are impurities. All right, so there it is. Process and product considerations. We're talking about chapter 19, Q7, which is aimed at the small batch, get people getting started in the development process. Here are the process development life cycle stages. Last week, we talked quite a bit about equipment, all the requirements for equipment, the need for the URS, how to assess risk on those, what was important, what the Q7 really says about the equipment. We talked about all that stuff.
How the equipment can potentially affect the final product.
And we're really going back to the scientific rationale for GMPs and APIs. So that's really what the purpose of development is. Again, just to put this in context, in our conversation in context, it's really the development of your process so that you can identify which ones are critical, which ones are not. And you use what's called a life cycle development process to get the data to really establish all that. Get the data to establish your process parameters, your equipment, which one is which. There's people with data and people without data, right?
Yeah.
You want to be the guy with the data.
Right. But not too much data.
Not too much data. Yeah. Not too much data. Just enough data.
Just enough.
If there's too much numbers to crunch, there's always going to be something, right?
Yeah.
So you want to have you want to have just the required numbers to crunch and not too much, because all those numbers cost you money essentially. So you don't want to be crunching data that's meaningless. Crunching the variability of the temperature in the room that we're sitting in that has no bearing or impact at all upon any quality specification. Okay, establish controlled process parameters, evaluate the sensitivity of the process. Okay, and this is what we went over last week. So we're going to continue along that just by really talking more about location and arrangement. Okay. A lot of times people, they want us to do a location and arrangement drawing for them. Okay. And that is for the equipment.
Yeah.
And it's always very specific to your operation. Okay. And a lot of people are like, oh, I can do that. I'm going to draw this out.
They see an example of one of the previous ones that
you used. We actually, if you contact one of our guys, you say, okay, hey, here's what I'm thinking of. We actually have a whole bunch of example arrangements that we have. What's not possible for you to do, really, and we know that, and the reason why we publish those things is for you to take that arrangement and then have something that's anywhere near reasonable and accurate for your facility.
There's no two that are going to work out.
Exactly. It's like an architect. You could take a drawing for one building and then you have to do it again.
Rearrange it for a different.
And also, there's a whole bunch of things you need to consider. Material flow and all types of material flow, where your waste is going, where your excipients are going, where your raw materials are coming, potentials for mix-ups, for example, where your airlocks are going to be, right? Yeah. Where your personnel are going to walk in and out of it versus where the material is going to come in and out of it. Egress is another thing that you need to think about for safety. And it's not just GMPs. We've talked about this before. It's safety, fire, business decisions, right?
Yeah, absolutely.
Right. Okay, so we could make something that's perfectly GMP compliant, that would totally destroy the business, and there'd be no GMP to follow because
you're not selling any products.
No, you'd be underwater. Access to utilities, for example.
Yeah.
Right? That's something that's really important. So here's a good example. Okay. Yeah, we typically have a CO2 conditioner, we have a CO2 pump, and we have a CO2 extractor, or we have an ethanol reservoir, an ethanol extractor, we have a pre-chiller, for example, or we have whatever. Okay. And those go into a room. They don't usually go all into a room. You need to have your storage facilities separate. Usually you need to have them in some sort of fire rated area if it's ethanol. And then once it goes into your ethanol extraction room, you have to have a C1D2, which is a classified area, or a ATEX 2 classified area room. So those are the types of things that you need to think about. In the case of CO2, you probably wouldn't put the process pump to fill up the CO2 extractor right next to the extractor because it would cavitate. You need to put that.
Wouldn't make sense. You'd want that over by what is supplying your cage.
It's supplying your cage, right? You're supplying your CO2 cage. That's the type of stuff that you need to know, and you wouldn't necessarily have all that process information.
Right, unless you've done it before.
Yeah, unless you've done it before. Piping, sizing, and distribution. Let's talk about that. That's interesting. So as you have a glycol, like you got chiller unit, right? You got a big outdoor chiller unit.
Yeah.
And you're going to distribute that. You have to be able to distribute different flows, different temperatures, maybe even to different processes. If you're going to have one, those pipes have to be made of a certain size with all the bypasses and all that stuff. So what they call it a P&ID diagram.
Okay.
Which it says, okay, here's my process, here's the pump, here's the valves, here's the check valves, here's the piping, here's where it all goes, here's all the dimensions on that, everything. So, and then each of the valves are labeled, and you can have all the valves and all the process labels and all that stuff. And then each of the pipes are also labeled.
Yeah.
Remember, like in the equipment section, it says that all the process pipes and utilities should be labeled what they're for. So that's a GMP requirement. Okay. Piping, sizing, and distribution of vacuum, compressed gas, cryogenics, process vacuum, and venting. Okay. So how to vent it? Where does the process vacuum go? Are you going to have a vacuum pump sitting there going off
right there
all the time with the oil that's in there, spitting out, vaporizing? You got an anti-vaporizer in there. Don't worry about it. Oh, really? You want that in your process? So forget about that. You're going to have it out and you're going to pipe it in. That's what we all do. Or you have something that's oil-less, but then those are a little bit louder, except for our Clear Still, which has the most expensive, most beautiful maintenance-free oilless pump, of course, because that's for a different reason, because we don't want to have contamination of the oil back into the distillate.
Going into the material.
Into the distillate, On the distillate machine, the Clear Still 400 and Clear Still 200, we have two condensers. We have a cold finger. And then we have like a coil finger that's supposed to condition it. So you'd think that oil would condense on those two things, and probably it could. Yeah. But you still get stuff that goes back. Nothing's perfect.
You got Dr. John looking at it. He's going to find it.
Yeah, we're going to find it. We're going to look at it. Okay, so process equipment, location, and arrangement. Again to that. Material flow through the equipment, waste flow out of the area. That's important, right?
Oh, yeah.
These are things that you need to consider, okay? When you are developing your process, again, this is all in context of development, right?
Yep.
Which reminds me, and we touched on this last week, and that was just when you develop your process, you have to go in, you do your risk assessment, define all your parameters, you define your quality parameters, you define your specifications, you're doing all this stuff, and then what do? A design review, right? And then you iterate your design, and then you do another design review. So you do a couple of them, depending on what your particular process is. Well, the key thing is that you need to document your design review with a documentation package, okay?
Yeah.
And you have to have an agenda. Were there any action items coming out of that? What did you change? What it was? That's the part of the design process. Again, that's the life cycle process. So that's what we typically go through. When I'm doing a design, let me tell you how I do it, okay? When I do a design, typically I start with block diagrams. Draw a square. That's my area for extraction. Here's my area for distillation. And then I start to arrange them, and I'll put in the corridors if I can. I'll put in the materials corridor. I'll put in the personnel corridor. I'll put in the airlocks. I'll show all those. And then I'll draw lines where everything is going to make it logical flow of materials. And sometimes you can't achieve your flow because of the location or the area, or you're constrained with just the space. You can't achieve it. There's lots of constraints. If you have had doors with a square building with doors on opposite in a garage, which I've seen, very difficult to really conceive of how to protect it. You need level 1 protection, level 2 protection, level 3 protection, or a lot of people call those ISO clean rooms or clean areas or whatever. And I had one just recently that I had said, hey, look, I'll do a layout here for you on this, just quick conceptual layout.
Yeah.
It took me almost 2-3 hours to do. I was just like, because
you couldn't make it all fit in
No, I couldn't do it. It was just like, okay, I'm doing this, and then I'll do this, and then I tried to move it over, and it was difficult because you got to be able to pass the hallways.
You can't have a 2-foot hallway?
Yeah, no, it's not. Access to cleaning and maintenance areas. A lot of times the cleaning areas, because it has water in it, you want to have it maybe away from your other areas. And in that case, you'd have to be rolling equipment. It'd have to have quick disconnects for everything if you did that.
Yep.
Or if you want to have CIP system, which is a clean in place system, you'd have to pipe that in and out of your facility.
So you have somewhere so that waste is going where it's supposed to and not in a bucket.
Right. And you'd also have to make sure that the manufacturer knows that you want to interface to a CIP system or whatever so they can hook up to it and that they have the right fittings to hook up to it. Yeah. So that's another thing. It can get complicated, like with your typical piece of equipment where you'd have usually compressed air or inert gas. You'd have venting, multiple points of venting. You'd usually have process cooling or heating connections. Those are another 4 connections. Then you'd have output connections for output products, and then you'd have input product connections too. So now you have to have a list with all of those connections along with all the specifications on those connections, and then how they're terminated. And where's the process coming from? Is it going to be just on the floor, or are you going to have it on the wall, or are you going to drop down from the ceiling? Your electrical connection. I forgot the most important one. So those are the things you need to think about. That's why you need experts. I get confused sometimes. Oh my gosh, I forgot that. Now, how's that even possible? I've done that before. I forgot about things, but
it's just so much to consider.
Yeah, there's a lot to consider, right? And you do standard stuff. The big problem that a lot of people have is they think that they can do it once and then they just copy paste it. It's never that way. Never. And you know what? That's where really you as the owner or you as the consumer of the consulting that someone's doing or the design that someone's doing, you want to make sure that they're not just copying and pasting from someone else's design, because you're paying for things that don't really fit with you in your particular situation, your intended use of your product, and they're over specifying, and then because you're flipping the bill. Yeah, exactly. Make sure that there's good management on that. Fire safety code requirements also is something that's outside of GMP, but would still be important for code requirements and things like that. Levels of control, that would be good GMP levels of control and things like that. Okay, drawings. You want to make sure that all your drawings also that you have when you start to make them and you develop the process. Again, we're talking about Chapter 19 of the Q7, which is the process development. That your drawings, your process drawings, all your process has all been gone through the risk assessment, and that you have all of the good workflow and a good process diagram with all of the processes that are critical outlined, along with the critical equipment, along with the process parameters that you want. And then make sure that you have all your P&IDs. Make sure that you have good arrangement drawings. Make sure you have good interaction drawings, okay? How's it interacting with your levels of control? How's it interacting with your ISO clean rooms? How's it interacting with those types of things? So you wouldn't want to go, for example, from a grinding process to a distillation process, for example. That would be a bad interaction. Because you go from a dusty area to with no gowning in between, to a high level of control area. Right? So those are things that are pretty obvious, but you need to think about.
You may not be thinking about it as you're trying to slap all those rooms together.
Exactly.
All the piping to those rooms. It's a lot.
Yeah, the other thing would be there's like air exchanges for a HVAC system. I'm sure we'll get into this later on. HVAC systems for fire and for fire ratings on their walls and everything, you'll have a certain number of air exchanges that you need to, if you have any chemicals, your chemical inventory. You need to be thinking about that. Oh, by the way, I forgot to tell you guys all about that. Okay, we'll do a fire plan for you along with a chemical inventory, specifying all the chemicals, whether they're open, closed. We typically do just a fire analysis, okay, and then we also do the fugitive emissions calculations, which are in the event that you have a spill in the room, what are the minimum number of air exchanges that it would take to keep the amount amount of vapor in the air under the lower explosive limits, 25% of the low LEL, which is what they call lower explosive limit.
Okay, to where like a spark,
so that it wouldn't, it wouldn't cause it to go. Gotcha. So usually that's a big HVAC system that allows you to do that. So is it 10 air exchanges per hour or 14 air exchanges per hour or whatever? Yeah, so things like that, right? Definitely. Also, it's good to do those calculations and have a third party do them rather than your HVAC manufacturer, because your HVAC manufacturer is going to maybe tip the scale a little bit, okay, and say, hey, we actually need 25, okay, when you only need maybe 5, okay?
Okay, all
and
right.
Over specifying it, we put a safety factor on there of 3x, okay? Oh, really? Okay, that's only costing you another $1 million. Okay, that happens, okay? And so you want to make sure that you have the right engineering calculations going into your system. So.
Absolutely. It can be an expensive mistake.
Yeah, it's
not mistake, but improper planning.
Yeah, no, what they do is they have the calculations done for some other thing, and they have their safety factors on there.
Yeah.
And because it's lucrative to keep it the way it is, and if nobody asks any questions, you know what I mean? So you got to ask some questions. And then the engineers are going to get mad at you and walk out of the room. Okay. All right. Cleaning considerations. Yeah, I don't know why engineers, they are a sensitive bunch.
Yeah, I was going to say they're touchy folk. Definitely. They're very sensitive.
Like, I need a 4X. Where does it say you need a 4X? It doesn't. Oh, really? Okay. Well, all right. How much is that costing us, right?
Yeah.
There are tremendous engineers, though, that are actually doing the work, I have to say. So I think you get what you pay for on that side. So make sure that you guys buy the best engineer that you can, because it's going to save you money.
Definitely.
Okay, cleaning considerations. This is, again, things that you need to think about when you are designing your process and doing your design.
I got to clean this stuff too now? What?
Look at this. Yeah, you got to clean it all. Okay. You got to have the idea of the processes. Again, going back to the requirements. This is in the Q7. There's a whole section in there on cleaning. It's all related to cross-contamination. Okay. It's all related to making sure that you're not contaminating it. So if you're going to put water in there with caustic or something like that, or you're going to have, you can clean it. Everything's going to be clean, but you don't want to have that residual in there.
Right.
No different than solvents. Okay. Yeah. So again, you have to have a validated and documented cleaning method. You have to have inspection and sampling procedures, and then you have to have test and accept criteria for the residuals, a testing program for the residuals, and you have to establish a max time between cleaning and clear identification of state of the equipment. Okay. All right. So these are the kind of the requirements that you would, when you're developing your process, this is what you would need to think about. Now, interestingly enough, there's a lot of different ways to clean things. You can do a clean in place CIP. We just mentioned that. You can do clean out of place, where you would require a disassembly procedure and clean some things out of place. There's a lot of leeway there, I think, in how you go about making sure something is clean. Okay, first of all, it's a risk-based thing. Yeah. If there's no possibility of cross-contamination, maybe you just want to say, hey, look, make sure that there's no free from foreign matter and debris, and that's good enough. Do a visual inspection. Okay. If you are worried about like phthalates, for example, okay, you might want to do a swab and test for phthalates. Okay, that's expensive, right? Yeah. You got to make sure that you're not just testing for everything, right?
Right. You know, something that's going to actually have an impact on. Yeah, impact on the quality and the intended use of the pharmaceutical API. Again, we're always going back to that. What are the specifications? What's the intended use? Will it affect the quality parameters at all? Right. That's the risk assessment. Yeah. Okay. For example, if I was using caustic, and I use pH as caustic is like a very basic pH, as a high pH number. So it's 14, 12, 13, 14, 15. Those are high pHs. Yeah, that's acidic, right? No, that's basic. Oh, base? Yeah. So caustic is base, So that would be like, and then acidic would be like Coca-Cola would be like a 4. Oh, water 7, HCl would be like a 1, acetic acid would be 5, right around 5. Recovered solvents. This is something you need to be thinking about, and too many people are not thinking about this. They're using their solvents again and again. They're sending out their products. The oils and the solvents get all janky. They get cross-contaminated with all kinds of stuff. They reuse them until they can't reuse them anymore, or they reuse them until they evaporate away, which is even worse. And then just keep adding more to it. Okay. And at the end of the day, it's not good for the consumers. They don't know what's in there. It's incorporated into the products, and they're like, oh, this is really great. Right. And look at how cheap this is. Look at how cheap this is. Without following any of the rules associated with solvent reuse. Okay.
The solvent reuse are very similar to the cleaning rules, okay? And that means you have to have a method. You have to have a validated method.
Yep.
You have to assess the risk of using recovered solvents on cross-contamination. You have to have a validated maximum number of times to reuse. How many people have you seen in the industry have a maximum number of times to reuse their solvents? That was a poorly formed question, but
no, not very many.
I have seen it in Canada, and guess what? It's super expensive to run ethanol in Canada because guess what? They're following GMPs. They're following GPPs.
How many times can they use it before they have to?
One time in this particular.
What?
Yeah, so they use it once and then they throw it away.
Wow.
Yeah, because they are worried about cross-contamination.
Again, it's a legit concern.
Or within a batch. Okay, so if I have 10 batches, every time I do a batch, I have to change out my solvents.
Okay.
That's not economically viable, guys. And in fact, if you're using quality ethanol, it's definitely not economically viable. And everybody's, we got to go ethanol. We're going to GMP. That's you're not doing the math. You're following the lemons, who are basically lemming, just like a lemming. You are following the lemons. You're going the California way, and also you're not doing the math.
No.
And you're not understanding your process. You're not doing the risk control. So you got to do these things. And when you create your process, in fact, recovered solvents are a huge thing that you need to be considering. Okay.
Yeah.
Maximum times to reuse, which is required by the valid guidance given by the US FDA, in fact. They've looked at this and they say, hey, look, guys, you got to. Interestingly enough, the US FDA has also established very extremely liberal limits on the amounts of harmful chemicals that are allowed in your food and in an API chemicals, right? 5,000 ppm.
Yeah.
That's a lot.
Especially if it's something you're consuming regularly.
Yeah, exactly. Okay. The federal government guarantees that you have 0.001% less than rat feces, and also 500 parts per million or less hexane. Okay, but it used to be 5,000. But now it's 500. Man. Okay, so it used to be 5,000. So all those poor people back in the 70s and 80s
who were rat feces and hexane?
Hexane, yeah, hexane extracted rat feces. Oh, that's bad. Okay, but at the end of the day, look, guys, the deal is everybody knows I have a strong axe to grind with the limits on solvents that the FDA has allowed under influence of none other than the pharmaceutical manufacturers. Yeah. And it's all available. You can go check it online. Yes, I do believe that there's a FDA pharmaceutical industrial complex, and they have a huge impact on the FDA. No surprises there. But don't worry, we have evaluated the amount of solvents in your food, and we've found out it's totally okay for business. It's totally okay for business. It's very business friendly.
Investigating themselves a deal. Yeah.
What's this weird taste in here? Oh, don't worry. That's totally good for business.
It's safe.
It's great for business. So. Okay.
Yeah.
Identify and and then it's safe. And then about 10 years later, oops. No, we need to dial back a little bit because now we're seeing stuff. It's not working.
We didn't see that 10 years ago.
We didn't do the research now. So maybe they should follow the Q7 and validate their numbers that they put out. How about that?
You would think.
Okay, we did. We tried it. We injected 10 Sprague Dolly rats with 300 parts per million, and they were fine because when we asked them what was wrong, they didn't say anything. No, that's actually what happened. Okay. Man, there we go. Okay, identify impurities and reclaim solvents, establish maximum levels. Okay, yeah. Okay, so you take a solvent in and you extract it, right? What are the impurities that come out? Okay, so you're distilling it. Great. Oh, that's wonderful. You're distilling it. Yeah. But guess what? Anybody who's ever done this before, you get stuff that co-distills all the time.
Yeah.
You just do. Okay, and then what do you do with that? Then what do you do? Because it's got impurities in it, you have to establish the maximum levels. You have to understand what the impurities are. The problem with the establishing the impurities is that if you're doing different batches of biomass,
different impurities are going to pop up over time.
You don't know. So then you find out something, you're like, okay, the best way to deal with that problem is not to measure it at all, ever.
That's the simple solution.
Well, out of sight, out of mind. Exactly. It's pure. If you don't measure it, it's pure.
Yeah.
So that is fine. No problem. See no evil here. Okay, so
great monitor movie, by the way.
Oh, yeah. It's all good. Monitor reclaim processes with QC sampling. Yes. That means sampling and testing with each batch since the inputs may be different. Okay, so let's go through this again. Let's recap. Assess risk of recovered solvents on cross-contamination. Establish and validate a maximum number of times to reuse. Establish specifications for the solvent. In other words, you have to say, okay, here's the solvent and there's the specifications for purity on the solvent. Okay.
Yeah.
Now, Does that, if you, okay, so I'm going to go take specifications from a manufacturer. Does that really work? No, it doesn't. Why it doesn't work? Because you don't know what the impurities are for your particular process that you're getting out of your biomass that you got from Farmer Joe.
And John,
we sprayed,
and Alex,
exactly.
and all the
John and Alex and Maggie and right, all these people that are out there, and you never know. You got really great organic actors, and then you have not so great organic actors, and then you have not so great actors, period, that are not organic or either way. You know, like, okay, right. So they'll be different. The impurities might be different. So I mean, we all know that the terpene expression is different. We also know the terpenes kind of stick with and co-distill into the ethanol.
Yeah.
Are those contaminants? What are they? You look at them. You look at them. Here's the other thing, guys, associated with this is, and this is the same thing with cleaning. Residues. If you take a sample of that and you put it into GC headspace, okay, if you're only going, because the limited detections are so terrible, there you're not going to see anything. It's going to be one big peak, and it's going to look clean because the way you're measuring it.
I see.
Okay, you put it into a GCMS or something like that, you're going to be like, oh wow, there must be 3,000 compounds in here because it's got everything. So it's got selectivity. So there you go, guys. That's a big deal. So you can, analytical chemists can actually cook the books. Yeah. In other words, they can be like, yeah, no problem. We'll have a high limit of detection. We'll put it through this detector that doesn't see anything, and then it's clean.
Right.
It's like using chlorofluoro or fluorochemicals to do your extractions.
Oh, it's not there.
No, it's not there because we can't see it. We can't measure it, so it must be perfectly clean.
Exactly.
Yeah, okay. Yeah, you can take that. Look, I don't believe that you should be imbibing chlorofluorochemicals, period. We had this situation like with DuPont and 3M, for example. Remember the PFAS and PFOA and all of that? Remember those are they're fluorinated surfactants. Yeah, and they're everywhere. They're in your body. Everybody who's listening to this has perfluorinated surfactants in their body right now. And the thought was that they're perfectly fine because they don't stay in the body very long, but then they found out they do stay in the body. And of course, the body does not break down. They concentrate in the endocrine system, and then they biomagnify. And they become biotoxic over time because you're taking it over time. Yeah. Okay. See what I'm saying?
Yeah.
Okay. So is that true for any of the other smaller chain compounds or anything like that? Maybe. I don't know. But we don't know. That's the point.
Right.
What's the effect on, it's not a food, right? It's totally, your body does not make a fluorochemical.
Not meant to break it down.
It's not meant to break it down. Yeah. So where is it going? Okay, so you feed someone, you feed a rat maybe 10 milligrams and you get 2 milligrams back out of the urine or whatever. Where'd the rest of it go? Well, your body's taking it. They're like, oh, we don't know what to do with this shit. Okay, let's put it into the endocrine system. Oh, that's a really good place. Okay. And they go over there. They're shoveling it up. They're shoveling it over there. And then you're like, okay. Then over time, maybe we just don't know. We don't know what it does to the cognitive system. Has it been studied? Okay. Maybe it hasn't. I don't know. You want to take refrigerant? You want to drink it?
No.
Okay, I don't know. I just don't get it. I'm very comfortable with CO2. Why am I comfortable with CO2? Because it's whatever. We make it. Your body knows what to do with it. It's a natural product. Plants eat it.
Still get a few haters that come in and
we do.
They really hating on the CO2.
They love CO2. They just don't know it yet.
Right.
That's probably
what it is.
And I'm not opposed to an ethanol extraction system at all.
Nothing wrong if you're doing it right.
Yeah, you got to do it. And it's also costly. And that's what we're talking about here with recovered solvents. If you put the recovered solvent cost into your cost flow for your operating cost and then add that to your losses that you're getting every day, you will find out that you are paying tremendous amount of money in solvent losses and solvent reuse costs that really don't work.
No.
And the CO2 is just so much less expensive than that. But the whole industry has been basically bought this lie that it's more expensive, and it's not.
No.
All right, guys, we have got to wrap this up. We have been opining on all kinds of subjects. It's been great. But you guys have a good day, and we'll talk to you guys later. This has been Extract Talks. John, Jared, and the crew. None other than
don't forget about James.
Not 1 million view crew here. Hey, make sure you click that subscribe button. So, yeah. By the way, we are at 1 million views on our...
Over 1 million.
That's a big deal for an equipment company. It's not like we're... Yeah, it is.
And all the education that we provide, I think that's definitely a big factor, and that brings people in.
Yeah.
What keeps them coming back.
All right. Thank you, guys. Take care.